Hey everyone, welcome to another video. It would help us out a lot if you could like and subscribe, and we actually now have a Patreon. So if you'd like to be one of our first Patreon members, that would really help us and let us keep making videos. So today I'm here with the mechanical engineer who's trying to learn how to program.
Hey there.
So we're starting to get, I think you're starting to get pretty good at this. So I think today we're going to do a really classic interview question to kind of get your confidence up and show you that you are learning a little bit.
Okay.
So this one is called TwoSum, and like I said, it really is a classic interview question. But the general idea is we're going to write a function, and the goal is to return the indexes of two elements that add up to a target. So the inputs to this are going to be a list and a number. You can call them nums and target. And then basically what we want to do is in some somewhat optimal time, we want to go through it and return two indexes. So we can return two things. And the elements at those indexes will add up to a target. So why don't you start by just writing the function definition. You can call it TwoSum. And then this will take in nums and target. All right, great. So just for reference, why don't you populate line 1 there with a list of numbers. Yeah, that's good. Let's do positive numbers. And then for target, just add up two of those numbers, and this is just a number, not a list. So for line 2 there, just make it an integer instead of a list of size 1. Just get rid of the brackets.
Okay.
So 15, so we want to return 7 and 8, and the indexes of those, so what is that there? That's going to be 4 and 5, right?
Yep.
So keep that in mind that when we run this, when we call it later on, we want to return 4, 5. All right, cool. So why don't you I'll let you kind of take control here, and yeah, very true. And you can just walk me through how you would solve this.
Yeah, so the first thing that comes to mind is that we could run through the nums list and figure out if two elements add up to 15. Seems like pretty basic way to do it. Just run through it one at a time, starting from 5 to 13, starting from the 0 index.
Sure, so like a nested for loop?
Yeah, so
use the proper terminology?
2 for loops, nested for loop, yeah. So for I and nums. But we probably only want to go until the end of nums. Kind of skeptical about this though.
Yeah, so a list, right? You can't call range over it, but you can call range on the length of it.
Oh, yep. So length of nums. And then
watch your
subtract 1, right?
Yep, I was gonna say watch your off by 1 error there.
How's that? Oh, inside.
All right. So now we basically have 2 running indexes.
And so if nums I two numbers equal 15. Can we use this?
Yeah, so we're running a function, right? And we want to make sure that this is good for multiple inputs. So instead of 15, why don't you use target?
Oh, sure, yeah.
And watch your double equals for comparison.
Yep, that was messed up. All right. Then we want to print I and j, right? Because we want the indexes.
Yep, but because we're writing a function, why don't we just return them? So instead of print, you can just type return.
What's like the difference between return and print?
So in a function, when you return, it's going to quit out of the function. And if you were to call that, so basically like calling
like
TwoSum will
yeah.
return a tuple with 2 indexes
So
rather than printing it and doing nothing. Like if we
Okay.
wanted to say we have a function and we want to use it later on, then like say, it returns something that we want to use, we want to return it so we can actually use it somewhere else.
What's the end condition for a function?
Return will get you out of it.
So this is kind of like the same thing as saying return ij, right?
No, so this actually this will return none. This won't return anything.
Oh, okay.
Again,
okay.
like you use return
out. Gotcha.
So when you actually call the function, you can just print the call to the function.
Mm-hmm.
So all right, I think just for style on line 9 there, just get rid of the space for nums j that you have for indexing. Yeah.
Would that have still worked?
I think it works. Yeah, I don't know. To be honest, I've never done it. Anyway, so line 12 there. Why don't you just call TwoSum with nums and target there?
So run this?
Yep.
All right.
There you go.
Sweet.
So you came to this pretty quickly. It's kind of it's called like a naive solution of brute force. So the runtime of this is going to be n squared. We talked about runtime a little bit, but just to think about it here. So on line 7, if the length of nums, our list there is n, then we are going to run through that n times, right? And then for every n, are also, yes, so the length will be n there too. But now because for every element in the list, we are going through n times, that's going to be n times n or n squared.
Okay. That's important to note in case the list is very long, correct?
Right. So then, if you have 10 million squared, we'll be hanging around here for a little while when we watch this thing run. So this is good, brute force solution, n squared time. So now can you think of maybe adding space? So by that, I mean like adding maybe some temporary buffer or some data structure that we've talked about or data type. And basically, let's reduce this to only one pass through our nums list. So O of n time now. And basically, think of a way to kind of add some memory, we'll call it. Just lightly call it memory, but some way to remember what we've seen so that way we don't need to loop through it twice or nested like we have here.
I'm not quite sure how to do this, but I think we want to use dictionaries in some capacity.
Yeah, so actually, if you remember, we did like a character count thing where we were going through and we only had to pass through one time. We were adding things to it. So why don't you just declare a dictionary on line 6 there?
In here?
Yep, call it whatever you want. That works.
Empty?
Yep. So then now let's just remove lines 9, 10, 11, 9, 10, and 11 there. You can keep the for loop, though. You can keep the top 4, though, because we're going to, again, go through one time.
Okay.
So now what I want you to think about is our target is 15, right? So just in plain English, what we're saying is if I go through the first iteration there, we're going to get 5, right? That's our first number.
Yep.
So what are we looking for?
For 10. For target minus I.
Exactly.
Or for target minus nums I.
Right. So what you can do is remember that dictionaries have constant lookup time, meaning instead of looping through an entire array, you can just get direct access, so it won't kill our runtime. You can actually just say like you just mentioned, it's target minus the element we have. So we can store that complement to the number. So the complement for 5 is going to be 10, right? We can store that as a key in our dictionary, and then as the value, we can just basically put the index that we saw the first number, so that way when we have to return the indices later on, we still have access to it. So why don't you just type that up? So it would be, let's see if you can remember how to do these. It's a little tricky, but So dictionaries, to add a new element, you can just do it the same way you would index a list. So you can use a square bracket. And then, like you said, we want target, right, minus nums at I. And all we want to store there is, no, you don't need the comma there, you're good. And then all you want to store there is the index that we're currently at, because basically we're saying the index we saw this element is 0 in the first pass at least. So that's I in this case, right? So we're saying the index we saw our first element is I and is stored at the complement of what we need to find later.
Okay.
So now at any point we see 10 in our list, all we have to do is return the current index, which is I, and then return the index that we saw the complement to that number. You follow me?
Yeah, a little confusing, but I think I get it.
All right, so this is kind of our like general case. So this is assuming that we haven't seen this number. But now, when do we actually want to return? When are we good to go? When do we know that we found two numbers that add up to the target?
We need an if loop, an if statement.
If statement, yep. So this will be our return case here. So this is, we've passed our, what we're trying to accomplish.
So if we've seen the number before, is the complement. Like if we've seen this number before in our dictionary, if it's stored in our dictionary, then we want to return true, or we want to return, the indices of those two numbers.
Yeah. So basically, if we come across a complement, then we just want to return the two indices.
Yeah.
So for that, you can just say nums at I, because remember we're iterating through all of them. So this means if we found the complement, which means if nums I is in our dictionary, because we previously stored it, right? Then all we want to do is return, and this is kind of weird, but you want to return the basically the nums I index of the dictionary. And then I. But the only thing on line 11 there is you're basically saying you're indexing your dictionary with the counter we have, our I. So instead, we actually want nums at I, because remember, we want to return because our complement is going to be there, right?
Yep.
So close, but now we actually want to index our dictionary with nums I. So it's going to be like a nested looking thing there. So it's bracket num, yeah. Exactly.
Oh, I see. Yeah.
Okay. So now there's one thing we have to change. So you have our general case on line 9 there. So now we don't want to do that first. We actually probably want to put that in a way that it won't execute. If we get because basically we want to break out of here if we see it originally. So yeah, exactly. We want to break out. So if we find the true case, then we can just return out and move along. But otherwise, we have to do that general case.
Okay.
All right. So now, why don't you let's run this again. We'll see if we get the same.
All right.
There you go. So now, runtime for this one. We're looking at O of n. So line 8 there, we're iterating through an entire list, right? So big O notation, you'll hear that a lot, is basically just worst case.
O of n, you said?
Yep. And then our space complexity, this is a new thing I haven't really talked about, but so there's time complexity and space complexity, and they both work with this big O notation, which is worst case. So now basically what we did, which is a really common theme, is we traded space for time. So our dictionary there is going to populate to a size of n, right? A length of n. Because if we went through every single element in our list, we're going to hit that base case on line 14, and we're going to add the element to the dictionary, right? And there will be 2n things in that dictionary if you include key value, but in reality, our length is n. So now our space complexity is also going to be O of n. Okay.
And is the time versus space trade-off, we would rather have more space and less time, correct?
So that's that's like really dependent on the problem at hand. So sometimes you really don't want to add any extra space, and sometimes you really want a quick algorithm and you don't care about space. So that really comes down to, I would say, for the most part, if you can come up with a more time efficient solution, that's, I guess, more impressive, and also a little bit, because like we just said, right, like it's pretty bad if we're going to be running for 10 million and we event square versus just 10 million iterations, which won't take too long. So I would say there isn't a answer to that question. It's a good question, but again, it really comes down to like your interviewer, what they're looking for. As you progress through and you're like building out systems, you'll have to make that decision if you want to trade space for whatever. So, I mean, memory is becoming super cheap, so computer space is too much of an issue. Yeah.
Gotcha.
So the takeaways for this one, whenever you get asked these questions, you basically want to get that brute force solution that you did within 2 minutes, right? And then once you get there, then it becomes kind of like a back and forth with your interviewer, and you can start to work towards this more optimal solution. So, yeah, hopefully that gave you some confidence. Now that this is a classic interview question. Like, you can get asked this at big companies. It's kind of retired now because it is so popular, but at a time, this was something you would get asked at any of the big companies you know of. So, yeah, well, good job.
Sweet. Thank you very much.